To build a good retrieval model, we need to modify our models to rank documents instead of retrieving them based on Boolean queries. For example, our models look for documents that match completely and ignore the documents that do not match completely with the given query. This model is good for expert users who have a precise understanding of what they wish to retrieve from the given collection of documents. But most users are incapable of writing precise queries. Boolean queries also have a limitation that they either retrieve 0 results in case of the query not matching perfectly with any document, or they retrieve thousands of documents in a case where the query is too generic and matched all of them. This is referred to as the feast or famine problem in information retrieval. It also takes a lot of effort and skills to write queries that produce a manageable number of matches with documents in the collection. This is also problematic for and/or compound queries. Instead of retrieving a set of documents that satisfy a particular query, we would retrieve a set of documents such that the top document would have the highest score in relevance to the query. The second document will have the second highest score, and so on. This is called ranked retrieval. This also allows the users to use free text queries comprising of one or more words in human language instead of writing a complex conditional statement. The goal of ranked retrieval is to build a search engine. There are 3 steps in creating a search engine. They are mentioned as follows. Step 1. Indexing and pre-processing. Step 2. Retrieve relevant information. Step 3. Evaluation of the retrieved results. Ranked retrieval also has the advantage in that larger sets of documents retrieved are no longer an issue. We can simply ignore the remaining documents after retrieving a certain number of documents and still would have the most relevant documents at the top. For example, suppose we only show the top 500 documents retrieved for a particular query. This set of 500 documents would contain the most relevant documents for that given query. In contrast, with the ranked retrieval model, the Boolean retrieval model has a few shortcomings. The retrieved results are not sorted based on any ranking mechanism, whereas in ranked retrieval, the most relevant document is at the top. It suffers for the feast and famine problems. One thing to point out here is that the quality of the ranked retrieval model depends on the quality of the ranking algorithm. Since this algorithm works by assigning scores to each document based on this score, we rank them. If the scoring algorithm performs poorly, then the documents retrieved and the order in which these documents are arranged will not give much value. Since our goal is to return the documents in an order which is most likely to be useful to the user, so we need a good scoring mechanism. Here, the goal of the score is to tell how well the document and the query match. A scoring model which is no longer in use today is the JACCARD coefficient. It assigns a score between 0 and 1. It is commonly used to measure the overlaps of 2 sets. These 2 sets do not have to be of the same size. It also doesn't consider the term frequency. This means that the rare terms are considered the same as frequent terms. This is a problem because rare terms in a collection provide more information and thus help us identify particular documents as opposed to frequent terms such as the, a, if, is, and, are, etc., which are less informative. For a perfect similarity, it assigns 1, and for a perfect dissimilarity, it assigns a 0. The formula is given as follows. Another model, which is the bag of words model, is commonly used. It doesn't take the positions of the term into account. This is also a problem because of the following 2 sentences are considered equal for a bag of words model. Car A is faster than car B. Car B is faster than car A. It only considers the frequency of the terms for scoring. This is a problem because raw frequencies have the issue that the length of the documents are not considered, and thus larger documents might be scored more because of high frequency but may not provide relevant information. A solution is to minimize the effect of raw frequency while still providing a score based on frequencies is to take a log of frequencies. You can also divide the term frequency by the length of the document to have a normalized frequency instead of the log of frequency. This does not reduce the effect of the length of the document on the score, but this still does not solve the problem of the term's position in a document. Term frequency, TF, of term T in documents is defined as the number of times that the term T occurs in document T. The relevance of a document with a query should not increase proportionally with the term frequency. A document may be more relevant with a higher occurrence of the term. For example, a document with 10 occurrences of a term is more relevant than a document with only 1 occurrence of a term. But this does not mean that it is 10 times more relevant. We also want a high weight for rare terms in a document as they are more informative than frequent terms. Another frequency known as the document frequency of term T is the count of documents containing a particular term T. Common terms have high document frequency. A document containing rare terms are more likely to be relevant. Note that a document frequency can be less than and equal to the total number of documents for any term T. Document frequency formula can be considered as a fraction. Unfortunately, this fraction is arranged such that it assigns a higher weight to common terms. To get a higher score for rare terms, we invert this fraction. This is known as the inverse document frequency formula. Again, to reduce the effect of high frequency terms, we can use logarithms. This gives us a modified formula for the inverse document frequency. Suppose there are a total of 10,000 documents, that is, n is equal to 10,000. The following table shows how the inverse document frequency is used to score different terms based on how frequent they are.